Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. How are you, everyone? I hope everyone is doing good by the mercy of Almighty Allah. Welcome to my channel, Easy Learning with Sadman Sir. And in today's video, we are going to discuss about Archimedes Principle. So let us go through the statement first. So the statement goes like this: when an object is partially or fully submerged in a fluid, the apparent weight loss is equal to the weight of the displaced fluid. So we understand what we mean by submerging an object in fluid. Okay, we already saw the case of buoyancy. Now what do we mean by weight loss? Now whenever we keep an object in, let us say, water, it feels a little bit lighter, right? Okay, if I show you this picture, it will be a little bit clear. You can see that there are two pieces of a stone, both are same size of and same mass. Okay, so it should have been balanced, right? Whenever we hang them, it was actually balanced, but when we kept the other one in the water, what happened? This side become a little lighter. That goes to show that this is not experiencing as much weight as this one, right? Okay, this side is not experiencing as much weight as this side. Now why is it that? We already studied about buoyancy, correct? So we know that a liquid exerts a upward force, okay, that makes the body actually lighter. I will give you another example. Let us say you are holding an object in your hand, and it seems a little heavy to you, and seeing that a friend of yours comes to help you, so he lends you a hand and he provides you an extra support from downward. Okay, from on the bottom surface, in the upward direction he exerts a force. So as he is helping you now, the object will feel lighter to you, right? It will be a little bit easier for you to lift up. So that is what is actually happening whenever you keep an object in water and try to lift it. Okay, try to hold it. What will happen? You will feel it is lighter. Why? Because water is your friend now. Water is providing an upward resultant force, which we call buoyancy, in the upward direction. As a result, it becomes a little lighter. So as the object is felt a little lighter, so we can say that there is an apparent weight loss of the object. Now why do we say apparent? Because this weight loss is not really actual. Okay, it's not real. It seems to be losing some weight, but in actual, the weight does not the mass remains same and the weight also remains same. It just feels a little lighter. Now it is equal to the weight of the displaced fluid. What do we mean by that? If you notice this figure, you will see that this is an object hanged from a weight machine. Okay, this gives us the value directly in Newton, let us say. And there is a bucket full of water, and there is a pot kept beside it. So if any water drips from here, then we can collect the water in this pot. So before we submerge the object in the liquid, you can see that the reading shows 7, means the weight of this object is 7 Newton. Now what happens in the second case when we have already submerged it in the liquid? So the buoyancy will act on it. We know the upward resultant force that is exerted by the fluid. So let us say this one is 3 Newton. So what will happen? Now here the weight of the body in this meter will not be shown 7 anymore. It will be shown 4. It will be reduced by 3, right? Because 3 Newton of buoyancy is acting on it, so it will become lighter by 3 Newton. Now this is what is weight loss. Weight loss is how much? 3 Newton. Okay, it was 7 before, now it is 4, so it lost a weight of 3 Newton. So let us discuss about the weight of displaced fluid now. Now we know that as the bucket was full of water, if we submerge the object in it, definitely the water level will rise and some water will fall through this path, right? And it will be accumulated in the pot kept beside it. So here let us say we have collected the amount of water. Now if this is called the displaced fluid actually, okay, because when the object went inside the liquid, it displaced some water, and that amount of water actually went out of the bucket and it was accumulated in this pot. So if I measure the weight of the fluid now, it will be 3 Newton exactly. This is what Archimedes has said. Okay, so this is the displaced fluid, and weight of displaced fluid is 3 Newton, which is equal to the weight loss of the object. Okay, so the apparent weight loss of the object is equal to the weight of the displaced fluid. I hope this is clear now. um, we will see a simulation on this. Okay, here what you can see, you can see that there are two objects. Okay, both are of 5 kg, and we have got two weight machine. One is kept in the air and another one is kept in the liquid. So let us measure the weight of this one now. First, we can see that the weight of this one is 49 Newton. Yes, we know it will be 49 Newton because weight W is equal to m into g. That means mass into acceleration due to gravity. So 5 into 9.8, if you do, you will get 49 Newton. Okay, so the weight in air, it is 49 Newton. Now let us see whether it becomes lighter when we keep it in the liquid. Okay, so we will place it on the weight machine kept in the liquid. Now you can see that the weight is not 49 Newton anymore. The weight, it is showing 24.5 Newton. That means definitely this object has lost some weight. Why did it lose some weight? If we see the forces acting here, we will clearly understand. Now gravity is what is weight, right? Okay, so weight, it is 24.5 Newton and it is acting in the downward direction, correct? And if I ask you about buoyancy will be acting in the upward direction. Okay, so both resultant is 24.5 Newton. Okay, if I click on the forces values, they will show you that what is actually the weight of the body, 49 Newton as it was in the air, and then 24.5 Newton force of bones is acting in the upward direction. So as a result, this force, okay, got reduced by 24.5. As if you remember, we talked about finding out the resultant force, right? I will explain this now in the slide. Let us go back to the slide. Okay, yes, we already saw these pictures, and as I was explaining, if 10 Newton force is acting in this direction and 7 Newton force acts in this direction, we already discussed about this example in the buoyancy video, I guess, right? So the resultant force that will act, it will be in this direction and it will be 3 Newton. Similarly, the object that we saw, okay, the weight of the body was acting in the downward direction, that was 49 Newton, right? And when it was in the air, no buoyancy was there. Actually air is also a fluid, so little bit of buoyancy will be there, but that is negligible. Okay, okay, but when we keep it in the water, the buoyancy that will act on the object is significant, and we saw that the force of buoyancy is 24.5 Newton, correct? So as a result, if I tell you to find out the resultant force of this one now, then what will you do? 49 minus 24, right? So you will subtract 24.5 from 49 and you will get 24.5, and that is acting in the downward direction because this force is higher. Okay, so the resultant force will be acting in the direction of the larger force, and resultant force will be found out by subtracting the smaller force from the greater force. Okay, so that is why it was showing 24.5 Newton. So you can see that when we kept it in the air, it was 49 Newton, and then when we kept it in the liquid, it was 24.5, right? Okay, I hope this is clear. Now this is what our scenario was. In the air, 49 Newton, and we keep it in the water, it becomes 24.5. So if I ask you how much weight it has lost, so it can be calculated by weight in air minus weight in fluid. So weight in air it was 49 and weight in fluid it was 24.5. So definitely if we subtract it, 24.5 I will get. So this amount of weight has been lost by the object. So this is what is our weight loss. Okay, now what Archimedes principle say, that this weight loss is equal to the weight of displaced fluid, right? This is what Archimedes principle says. Now as we got already weight loss equal to 24.5, so can I write that this one is also equal to 24.5? Yes, I can write it. Okay, so the amount of water that has been displaced by this object, whenever we keep it in the water reservoir, you can see that the water level is not same anymore. It is 100 and here it is 102. So definitely it has displaced some water. If I take that water and measure the weight of it, I will get that is showing 24.5 Newton. Okay, so weight loss is equal to the weight of displaced liquid by the submerged part of the object. So I hope this Archimedes principle is clear to you. If you have any question regarding this one, or you have any doubt, or if you need further explanation, please let me know in the comment section. Inshallah, I will be happy to get back to you. So everyone stay well, happy studying. Assalamu alaikum wa rahmatullahi wa barakatuh.